Hey guys, today we're going to be talking about slope-intercept form, day 2. Hey, remember last time we learned that you have the form y equals mx plus b, where m stood for our slope and b stood for our y-intercept. Okay? So we want to use those two things to go ahead and help us learn to graph. Okay, so we have our first equation here, and we see that we have y equals mx plus b equation, so we can see that our slope would be the number in front of x, and our y-intercept would be the number after x. And we can go ahead and use those to help us graph. And we always graph our y-intercept first. So this case, our y-intercept was 3. So we're going to go ahead and graph a point of 3 right here. Okay, so we have our point of 3, and we have our slope. Remember, slope needs a rise and a run. Okay, well, if you have a slope of 5, you have a rise of 5, a run of 1. So from that y-intercept, I'm going to rise 5. 3, 4, 5, and run 1. Okay, so there you have your 2 points, and then you can go ahead and draw your line through them. Okay, so that is graphing when you have it in slope-intercept form. Okay, but sometimes you're going to have graphs that are not yet in slope-intercept form. And when you have those cases, you need to go ahead and solve for y. Okay, so in this case, we want to get this y all by itself. Okay, so let's go ahead and undo this positive 2x with subtraction. Those x's then cancel out, and we bring down all of our pieces just as we see them, solving for y. We've done this before. Okay, and this negative 2x and the positive 10, you cannot add those together. You have to bring them down separately. Okay, last step, we have to then go ahead and solve for y. So we want to divide by the term in front of y. Okay, so we divide by negative 4 on each of your 3 terms there. Okay, these negative 4's cancel. And lastly, we have y equals 1/2 x, because these negatives cancel. And another name for 2/4 is 1/2. And we know that 10 divided by negative 4 on our calculator would be negative 2.5. Okay, so there's our equation in slope-intercept form, y equals mx plus b, and we want to go ahead and graph that. Okay, well, we know our slope is going to be 1/2, and our y-intercept is going to be negative 2.5. So let's go ahead and graph these two things here. We know that our y-intercept's negative 2.5, so we're going to go down negative 2.5 and plot our point right there. Okay, so that's our y-intercept, and then our slope is 1/2. So from there, we want to go up 1 and then over 2. Okay, so if we plot our point, there you have it. And then we can, of course, go ahead and draw our line through those 2 points. Okay, simple as that. You're using skills that you've already known and applying them to some new concepts here. Let's try one more. Okay, once again, we wanted to get it in slope-intercept form, so we're going to solve for y. So we got to get it by itself, so we need to undo this positive x by subtracting x on both sides. Those x's cancel out, and we bring everything else down. 3y equals minus x plus 9. Lastly, we need to divide by the number in front of y. So divide each term by that number, which is 3 in this case. Okay, so those 3's cancel out, and our final slope-intercept form would be y equals negative 1/3 x plus 9 divided by 3 is 3. Okay, so our final form would be this guy right here, where we can go ahead and pull our slope, which would be negative 1/3. Remember, slope stands for m. Or we could find our b, or our y-intercept. Okay, so let's graph these. Our y-intercept on this one happened to be 3. So let's go ahead and graph our point of 3 here. Okay, so there's our point of 3, and we knew that our slope was negative 1/3, so we know that this should be a negative sloping line. So we're going to go down 1, and to the right 3, and plot our next point. And last but not least, as always, we can go ahead and draw our line through those 2 points. Okay, so this is just a quick refresher on how to use slope-intercept form to graph lines. All right, I would like you to go ahead and try this function out on your own, solving for y and graphing the equation. Okay, let's move on a little bit. Okay, while you have learned how to graph some basic equations, we haven't come across these type of equations yet. Okay, sometimes you're going to get x equals just one single number, and y equals one single number. And you need to know how to go ahead and graph these. Okay, so if we go ahead and look at this, this wants all of the x values that are negative 4. Okay, so if we go ahead and go over to our graph on the x-axis at negative 4, you can see this point right here would be the point negative 4, 0. Well, let's look at some other ordered pairs with x values of negative 4. You could go 1 up and get an x value of negative 4, 1. Or you could go down 1 and get an x value of negative 4 and a y value of negative 1. Well, you see that each of these points has an x value of negative 4. And if you go ahead and draw your line through those points, you end up actually having a vertical line. Okay, well, what do we know about vertical lines? We know that their slope is undefined. Okay, so anytime you have anytime you have an equation where x equals some singular number, you're always going to have a undefined slope. Okay, so be aware of that. Your second type of special line is where you have y equals a number. Now in this case, we want to see all the y values that are 10. So if we go over here and mark y equals 10 right here, we know that that point is at 0, 10. The y value is 10. Well, if you keep going, you could have a point here where you have 0, 1. Excuse me, we need to erase that. It's not letting me, of course. Anyway, we go ahead and ignore that one. We wanted all the y values of 10. Okay, so ignore this. Okay, if you went over 1 and up 10, you would have the ordered pair 1, 10. If you went back a few, you could have negative 3, 10. Well, you'll see if all those y values have values of 10, and you draw a line through it, okay, well, you in fact have a horizontal line. And what do we know about horizontal lines and their slope? Well, their slope is always 0. So we know that when you have y equals a number, your slope will always be 0. Okay? Make sure you have that down. Good stuff. All right, Before we do the last section, I have a quick joke for you. What do you call two fat people having a chat? Think about it. Think about it. A heavy discussion. Oh, yeah. All right. So we have a couple more problems here, and we want to go ahead and identify an equation that represents each of these lines. And we need to have two things to write an equation. One, we need slope. Two, we need y-intercept, and no particular order. Okay, so first, let's look for our y-intercept on this graph. Well, we'll see, since we get to the y-intercept right here, we know that you have to go up 1, 2, 3, 4. So our y-intercept, or our b, equals 4. And our slope, we know, is our rise over run. So how much do I have to go up to go from one point to the next? Well, it looks like you have to rise 1 and run 2. So if I put that on top of each other, we have a slope of rise 1, run 2, or a slope of 1/2. So we have both of those pieces of information, so we can now write an equation using our y equals mx plus b form. So since our slope is 1/2, we have y equals 1/2 x, and then our y-intercept is a positive 4. Okay, let's try one more of these, and then I'll send you off on your own. Okay, on this one, it looks like we have a y-intercept of -1, so our b is -1, and our slope, let's find our rise over run. We have to go down 1, 2, 3, so -3, and we have to run +1. So our slope, or m, would be -3 over 1, or -3. Okay, so let's go ahead and use those pieces of information to write an equation. So our slope was -3, so we have y equals -3x, and then our slope, or y-intercept was -1, so we have -3x minus 1. Okay. All right, I would like you guys to try these two examples right here and write an equation in slope-intercept form that represents each line. See ya.